Hey there, everyone. I hope you guys are doing well. Today we are going to look at this truss as a first problem. And so this is an interesting looking truss. As you can see, it has several members and there are some external loads or forces acting on it. And it's connected to the globe or to the universe through these two connections. One of them is just like a two-way force member only, and this one has just solid connection to the ground. So in this truss, we need to find the forces measured in these members CH, and CI, CB, and finally IH. Okay, to be able to do that, first let's draw the free body diagram. Okay, so here's the free body diagram, and we need to identify the forces on this free body diagram. So we have the usual ones here, which are known. This is 15 kilonewton, and we also have this one here acting at joint F, 10 kilonewton. What else do we have? Well, this is solid shot to the ground, so it can't move left or right or up or down. So this means that we can assume there are two forces acting, one in the x direction. I am going to call it AX, and the other one in the y direction, I'm going to call it AY. Okay? Is there anything else? Yes, this is a two-way member. As you can see, this is two force-way member. So it only has a force in the x direction. If I have to guess, this whole thing needs to go this way, so the reaction force should be in the opposite direction, and I'm going to call this Jx. If our assumption for the force direction is incorrect, when we solve the problem, the number is going to come back as negative, and then we reverse the direction, and that would be an easy step to do. But if we don't know exactly where it's going to go, we just assume whatever it is. My guess for this one, it is going to go to the left. Okay, is there anything else? No, so we need now to apply the summation of all the moments around A to be equal to 0. So for that, I'm going to say summation over all the moments around A is equal to 0. I just choose this point to start because it seems that it has a lot of unknowns, and maybe we can just delete some of the unknown forces like AX and AY while we are solving for this equation. Okay, let's see. So this one is going to rotate the system clockwise. So I'm going to say, since it's going to rotate the system clockwise, it's going to be minus 15 kilonewton, and it's away by 3 plus 3, because all of these are 3 meters. So this is also 3 meters. So this should also be 3 meters. So 3 plus 3, so that's 6. I'm going to say 6. Okay, and if we look at this force here, it's acting also clockwise, so I'm going to make it minus 10. Minus 10 times 3 plus 3 plus 3, so minus 10 times 9. Okay, good. Now this force, Jx, is going to rotate it counterclockwise, which is positive. So I'm going to say Jx, and it's acting at 1, 2, 3 times 4, so that's 12 meters. And that's it. There is no other moments. These do not create moments because they are at 0 distance from the axis of rotation, and then we can say this is equal to 0. Okay? Now solving for that, we are going to get this is minus 90 plus 12 Jx, and that would be equal to 0. Then after some algebra, we get Jx is equal to 15 kilonewton. And look, it is positive, so our assumption of the direction was correct. So this force goes to the left. Good, so we found Jx. Okay, the only opposite x force in the whole system is AX, so we can conclude because of equilibrium that AX should be equal to JX. Or we can just say, using Newton's second law, at equilibrium, summation over all the forces in the x direction must be equal to 0. Then we can say AX minus 15 kilonewton must be equal to 0. Then AX is equal to 15 kilonewton. Okay, so this is the second force, and this is the first force. All right, let's see the force here, AY. We can say summation over all the forces in the y direction must be equal also to 0. Okay, now let's see. We have AY positive, and these two are negative. So minus 15, minus 10, so I'm going to say minus 25 is equal to 0, which means for us that AY is equal to 25 kilonewton. And that's it for all, identifying the reaction forces, if I may call them the reaction forces. Okay? All right. Okay. So now we found the reaction forces. Let's move on to what the problem is asking us to do, which is what? To find the forces on these members, CH, CI, CB, and IH. Okay, and where are those members? As you can see, those members are here. Those are the three members. So I am going to copy this free body diagram and put it down here. And I'm going to identify all the forces that I found. For example, AX was 15 kilonewton. So I'm going to put here, that's 15 kilonewton. And AY was 25 kilonewton. And JX, which is moving this way, was equal to 15 kilonewton. Perfect. Now let's highlight the ones that we are looking for so that we know where they are. And if I may use this here, so I'm going to say, yeah, this is 1. Okay. And this is 2. And this is 3, and this one is 4. So we have 4 members that we need to find the forces there. Okay, now we have 4 and they are well inside the truss, so using the joint method might not be the best way. We probably can start at least with the using the sectional method. Okay, remember when we do the sectional method we have to section that, so I'm going to use this. So I'm going to section that, but when I section it I can't section more than 3 members. So I can't go this way and then go this way. So I am just obliged to section this one. Okay, and now I'm going to draw this here, and then from here we will try using the sectional method to find the forces in these members and see where that gets us. Okay, wonderful. So let's look here now. We were able to copy this and put it here so that we can work on it as the sectional method. Notice something before we continue. We could have actually not drawn these here at all, these 2 members, IK and AK. Do you know why? Think about it a little bit. This joint here does not have any load on it, and these 2 members meet at an angle that is not 180 degrees. So these 2 are actually zero force members. So these are zero force members, both of them. Can you identify another zero force member here for us? I just want to remind you, here we have 15 kilonewton. And here we have 10 kilonewton. So these 2 cannot be zero force members at all, and the reason is they have loads on them. But can you identify another one at least? Okay, just one. Okay. Okay, now we have isolated our section and we identified all the forces. Let's try to, as an attempt to find the forces in these members in that section. Okay, maybe I can start here. I'm going to say the summation over all the moments about I must add up to 0. And then I can probably be able to find CB or BC, okay? I'm going to assume this one is going down to the joint as compression. And I don't know, maybe that would be a good assumption or not. We will see once we get the answer. If it's negative, we just have to reverse this arrow. Okay, so I am going to start with this one that creates a moment about I. So I'm going to say BC times 3, and it's going this way, so that is what, counterclockwise, so it must be positive. I'm going to also put this one here, it's counterclockwise about I, and this is the 15, which is that one was the AX. 15, and it's acting about 4 meters away. This one now, the AY, is making it rotate clockwise, so it must be negative 25, and it's acting about 3 meters away. So if you add all of this, should be equal to 0. Okay, so now, so this would be what? 3BC plus 60 minus 75 is equal to 0. So 60 minus 75 is minus 15. Take it to the other side, becomes plus 15. So 3BC is equal to 15. Then BC, force member, is equal to 15 over 3, and that is 5 kilonewton. And it became positive, so our assumption of it, decompression, is correct. So I'm going to write next to it compression. Okay, now let's find, maybe we're going to find what? CI or HI. Okay, what do we do here? We need probably to find, first of all, the angle, but we can go around without finding the angle at all. I'll show you how. We just multiply by the component of the, instead of multiplying by the cosine or sine of the angle, we can multiply by the ratio of that. I'll show you how. So this is, if this is 3 and this is 4, this should be 5, hypotenuse, Pythagorean theorem. So we can just use the ratio of that. So I can say summation over fx about this joint, or on this joint, must add up to 0, 2. Okay, so this is going, this is CI, and it's going with the positive x-axis. So how much of it is going positive? 3 over 5. Okay. What else is going? Is there any other x-axis forces? That is it, I think. Plus 15 is equal to 0. It's going to the positive x-axis. So CI, after some calculation, is equal to minus 15 multiplied by 5 and divided by 3. So this is what? This is here 5 times 5, so that's minus 25 kilonewton. If it's minus 25 kilonewton, so our assumption of it to be compression was incorrect. So what we need to do is basically to delete that and adjust the direction to be upwards, and this is tension. So CI is tension. Okay, and this is its value. Now what do we need to find? We need to find IH, and to do that, it's probably a good idea to use summation over Fy is equal to 0, and from there I have IH is positive. I assumed it was positive. Minus CI, and how much of it is in the right direction is 4 over 5 CI, 4 over 5, okay? And what else? What else of this one is plus 25, and I think that's it for forces. That would be equal to 0. And now, if we do that, so CI we found it to be 25. Since we changed the direction, I forgot to change the sign, so we should keep that in mind. So that's minus 25 divided by 5 times by 4, and that's IH plus 25 is equal to 0. And this is what? 5 times 4 is 20, plus 25, 45, minus, so you take the other direction, becomes plus. IH is equal to 45 kilonewton. 45 kilonewton IH is. And our assumption about it to be tension is correct, so that is going to be also tension. Good. Now the only member that we haven't found force on is this guy. Okay, so how do we do that? I suggest to use now the joint method. So we can focus on this joint, and from there we can find the summation over the forces in the x direction, summation over the forces in the y direction, and see where that can take us. Okay? Okay, so this is joint C from here. This is all the members that are connected to joint C, and these are the forces, or the forces in these members are the ones that we are concerned with. The idea here is we need to find what CH is, and that will solve the whole problem. Okay, so this is C. CD is unknown. I don't know, maybe I'll just assume it is going to be tension. Now CB, where is CB? CB is compression, so it's going to be towards the joint. And now this is IC. Look, IC here is tension, so it's going to be away from the joint. Is there anything else? CH, I don't know, we can assume, so let's try to guess. So this is going up, going down, going up. Maybe I can assume it's going this way, which means that it's compression, but we could be wrong. Let's see. Now let's solve here, okay? CB, we got it here. So I'm going to say summation over Fx, that's joint C, must be equal to 0. Okay, how much is that going to help us? Alright, so this is 3 as we remember, this is 4 meters, this is 3 meters. So this force here, which is CI, is going to the positive x-axis this way, and 3/5 of it is doing that. Okay, now anything else? Minus CH directly to the negative direction, and this one I'm going to say plus CD. Now what is this angle? We know again this is 4, although I didn't say that, but this is 1, 2, 3, 4 squares, so this is 4, 2, this is 3 meters. Okay, so how much of this CD is in the x-axis? Against 3 over 5. Perfect. Good. And that is equal to 0. Unfortunately, this one equation, 2 unknowns, it's not going to help us too much. So let's move to the y direction. Maybe we will get more lucky here. Alright, summation over Fy, we have CD. We write it in the same. And how much of it is going to be positive y direction is 4 over 5. This one, CB, it's positive, looks like. And, wow, this one here, minus, because it's going to negative y direction, 4 over 5 CI. And I think that's it. And that would be equal to 0. Now, CI is 25 kilonewton. multiplied by 4 divided by 5. So this whole thing goes into 20. Now CD is also given 5 kilonewton. So this is 5 plus here CD. Where is CD? Where's CD? That's what we need to find. Times 4 over 5. Okay, good. So 4 over 5 CD plus 5 minus 20 minus 15 is equal to 0. So CD is equal to 15 times 5 divided by 4. Okay? And if we do this correctly, we get CD is 18.75. So I'm going to write this here. CD is equal to 18.75 kilonewton, and it is positive, which means that our assumption about it, that it is going to be tension, is a good assumption. Nope, actually we take this number and we plug it here, because we know CI, we know CD, and now we need to find CH. Solving for CH, that will give us, right, so it should be positive. So it's going to be actually positive, and my assumption of the direction this way is correct, so it is going to be a compression force. And that's it for this problem. Thank you very much for your attention, and have a good day. Bye-bye.